Okay, Matrix, let's have a look at another few little types of examples. Have a look at this one. Y is negative x squared. Okay, how do we draw this graph? Let's call it f, the original. If you pick certain values here, you could say, let's choose -1, 0, and 1. How do we get the corresponding y values? We'll plug in -1 into there, so that's minus +1, which is -1 there. 0 is easy, and what would be -1 squared would give you -1. So that's easy. Now when we swap them around, we're getting the inverse. So we swap the y and the x around. Let's keep those values there. Okay, now if we draw this graph, okay, the two graphs there, what do we have? We'd have this here, it looks like that, and like that, and I'm going to go -1 like this. Okay, so the original one would be 0, 0, and here would be 1, -1. This would be -1 and -1. So this graph would actually look like this. Goes up, comes down, and goes down there. Let's put that point there, and there we go. So that's your graph. Okay, that's the graph of f. The inverse, if you look at this here, so would have been -1, -1, 0, 0. So it's -1, 0, 0, and then the other one was x's -1, 1. So that's there. Check it out there, -1, 1, if you read that off. So this graph, as you can see now, goes the other way. So it comes down, and there we go. A little bit different there, and that's the inverse, which is clearly not a function. If you had to draw a line here, it cuts in 2 points. So the question is, how do we restrict the graph? By the way, if you also look at the equation of this thing here, you could say, well, if you've got x is equal to -y squared, if you want the equation, multiply both sides by negative, and then go plus minus the square root of negative x is y. So this top piece here would be y is the positive version of that one, and the little bottom piece one would be the negative version of that. Okay, and notice in this case x is clearly negative, which helps because it doesn't make that thing non-real at the bottom there. Okay, so how do we restrict the domain to make both functions? Well, if you look at the original one, it looked like this. Okay, so that was your first graph, okay, which is going to be f there, and the original was not, so it looked like this. The original, or the inverse of the original, is not a function. So how did we do it? Well, the one way would be, if you look at the bottom graph, if I take that piece there, and I don't take this, in other words, I'm looking where x is negative, then for the inverse, it looks like a little fish, goes like that, and that will be, both of them will be functions now. Or the other case scenario, whereas if you take the right side here of f, then that would go down like this. Remember, this would be your little inverse there. Okay, the inverse would come like this. It would go down like that and across, and there would be your inverse. So it looks like a little bird. I call it a bird, and a little fish. Okay, and you create your little functions there. Whereas these two are not, this one's not a function, whereas the original is. Okay, look at another one quickly. So if you look at px is equal to -1/2 x squared, I'm not going to be too technical about this. I'm not going to put exact points. The rough picture here would be, this graph would be something like this. Okay, a sad parabola, and that's the graph of p. But if you invert it, have a look at this. The inverse would be a problem, because that would not be a function. So how do we restrict it? Very quickly, we can say, well, okay, if you take the original one, let's have a look at the original one. You can take maybe that piece there, ignore this, that's a function, and the other one comes down and does this. It looks like a fish. There's your inverse. Or you can go like this, take that piece for the original there, and this comes down here, and off it goes, and that would be the inverse, and both of them would be functions. So remember, if we summarize both cases, again, very important, if you've got a case of a parabola being happy or a case of a parabola being sad, okay, these are functions. The inverse of this one looks like that, not a function. The inverse of this one looks like that, not a function. So how do we restrict the domains for this one here? For this one, we can either go like that, and not keep that piece, and then the other one would go like this. Now they're both functions. Or you can take, so instead of going like that and that, or you could say, well, let's leave that piece and take that bit there, and then the inverse would go like that, and they're both functions. For this little chap over here, let's see what we get. Well, we can take the sad piece, we can go like that, and not that, and then the inverse goes this way, and there we go, we've got two functions. Or alternatively, we can go that piece there, for the sad one, and then the inverse goes like this, down like that, and again, both are functions.